All righty. Hello, everybody. I hope you can all see this presentation. My name is David Williams. I'm a research professor in the School of Earth and Space Exploration at Arizona State University in Tempe, a suburb of the Phoenix metropolitan area. And I am a person who works on NASA robotic planetary missions. And I've done quite a bit through my career looking at all different types of worlds in our solar system. The presentation which I'm going to give today is one I made for the Star Trek convention in Las Vegas about 2 to 3 weeks ago. And for that presentation, I linked the classification of the different types of planets known in the Star Trek universe to the different planets that we see in our own solar system and the ones that are being discovered, exoplanets, thanks to NASA's exoplanet program. So it has a little bit of that bent to it. So, but it's still, the point of this is rather than the Star Trek is more to talk about the great variety of worlds we are discovering, through our own solar system and now in other solar systems, exoplanets. So the title of this is Class LK or M with a question mark, exploring worlds through NASA's planetary missions. So to acknowledge the classification of planets in the Star Trek universe was sort of codified by Jeffrey Mandel, a fan and illustrator who wrote this book, Star Trek Star Charts, that came out, I believe, around 2001, 2002. And of course, all of the worlds that we visited, all of the worlds that are discovered through Earth-based telescopes are all funded by NASA and the National Science Foundation. So acknowledgements to all of the scientists and the funding sources that have enabled all of that. So what you see here is a chart that summarizes the state of solar system exploration here in 2021. And you'll notice on the left, the first column are the major planets and objects of our solar system, starting with Mercury closest to the sun, going all the way out to Pluto and the Kuiper Belt. And then going across the top, you see the different modes of discovery and exploration of these bodies. Of course, the first is telescopic observation. That's how it's been discovered. And then we go through the different types of robotic missions, flybys, where you get your initial data set, orbiters, where you get your first global data set, landers, usually your first spot when you contact a planetary surface, rovers, which provide mobility on the surface, robotic sample return, bringing samples of rock or dust or ice or atmosphere back to the Earth, where they can be studied in our labs. And then the final step is crewed missions, sending men and women, hopefully, to the surfaces of these bodies. So as one might expect, the closer you are to Earth, the more complete the sequence is. With the moon, you can see going across that we've covered all of that, the Apollo crewed missions, completing that sequence, although there's still a lot more that humans could do at the moon, and NASA is getting ready to do that, as we'll mention in a bit. Mars is almost all the way through. It has operating rovers, Curiosity and Perseverance, and we're in the Perseverance is the first step of collecting samples for a Mars sample return campaign, which will dominate this particular decade. When you go to bodies further away, we've had orbiters and landers on asteroids and comets. We've had orbiters at Venus and Mercury and landers and balloons too. And we have new missions coming up, which I'll mention. When you go to the outer solar system, it's a lot harder to get to, yet we've had some big flagship missions, Galileo, which I worked on, Juno, which is operating at Jupiter, 2 big missions to go to the moons, Europa and Ganymede, which will launch later this decade. We visited Saturn with Cassini, and there's a new drone, an aerocopter drone called Dragonfly that's in development right now. And then when you get out to the outer solar system, you're pretty much limited to either the Voyager flybys of Uranus and Neptune, and then more recently, the New Horizons flyby of Pluto and the Kuiper Belt. So what I like to say is our goal is to completely explore the solar system through all these modes, and then we'll be able to boldly go where no one has gone before with, as they say in the Star Trek universe. So let's jump in. This will be in this relatively alphabetical order. Not all letters of the alphabet will be used, but let's talk about in the Star Trek universe, Class A. These are geothermal worlds. These are rocky molten, probably have active volcanism on it. The planet Gothos in Star Trek, the original series, is a good template for that. In our own solar system, probably the closest is Jupiter's volcanic moon Io. This is a moon that is just a little bit larger than our moon, but as you can see on the spinning globe there, it looks very, very different. It's peppered with active volcanoes. This particular moon undergoes tidal heating. The surface of this moon flexes up and down about 100 meters every 48 Earth hours or so. And that flexing of the crust generates a heat to melt the interior to produce a magma ocean that powers all of these volcanoes, all of those dark spots there. You can see at lower left there from the New Horizons flyby an active near polar volcano producing plumes. These volcanoes can shoot gas and dust up to what would be the equivalent of the orbit of the International Space Station on Earth, partly because there's no atmosphere to help impede explosive eruption. This world has very high temperature silicate lava flows like we see in Hawaii, possibly very high temperature, very low viscosity lava flows like erupted on Earth billions of years ago. But it also has sulfur and possibly sulfur dioxide that not only is a volatile in the explosive plumes, but also could be in flows on the surface. So, this world is very desirous of a mission. And one was recently proposed to NASA called the Io Volcano Observer for the next Discovery class mission, which would be a Jupiter orbiter that would do multiple flybys of this world and really try and understand the nature of this world and what tidal heating enables this world to do in terms of its geology and all those things. Now, unfortunately, this mission was not selected by NASA in favor of a couple of Venus missions we'll talk about later. But I'm sure this mission or some version of it is going to be proposed at a future Discovery call because Io definitely is a world that deserves exploration. Next, we go to, in the Star Trek universe, Class B, Geomortis. So these are rocky worlds that have very, very high surface temperatures. They may have very, very thin atmospheres. And the analog in our own solar system is Mercury. And we know an awful lot about Mercury thanks to two NASA planetary missions. Back in the 70s, the Mariner 10 did multiple flybys of Mercury in 73 through 75, imaged about half the planet. But we learned a great deal more from the first orbiter mission to Mercury, which was named Messenger, which operated there between 2011 and 2015. The spinning globe is a false color view of the surface, and you can see it's very heavily cratered. The color variations show, everything from fresh impact ejecta to compositional variations in the crust that we think are due to ancient volcanism. You see the giant Caloris Basin as it rotated across over there. So it's a very heavily cratered world. It has extensive ancient volcanic plains. There's evidence of explosive volcanism when the planet was a lot hotter. It has a very, very large iron core that makes up most of the interior mass, but it's very hot on whatever side is facing the sun, very cold on the other side. There's more to be learned about this world, and the European Space Agency launched a mission there back in 2018 called Bepi-Colombo. This will also be an orbiter mission. It's actually a partnership between the European Space Agency, which has sort of a geophysical orbiter, and then the Japanese Space Agency, JAXA, has a magnetospheric orbiter. So it's got a whole range of instruments to study the surface, study the magnetosphere, the particle interactions between the sun and Mercury. So what we didn't learn from Messenger, we'll most likely learn from Bepi-Colombo. And the arrival is in 2025. So it has to pump down its velocity by doing multiple Venus and Mercury flybys. And you can see here, October 2021 is the first Mercury flyby by this spacecraft. So it'll be collecting science on the way as it moves out there. So Star Trek Universe Class C, Geo inactive. These tend to be frozen worlds made up of ice. They may or may not be cratered. In the Star Trek universe, Psyche 2000 from an early original series first season episode, or in our own solar system, Pluto. Now, Pluto was the one world that hadn't been explored by the Voyager outer planet mission, so a specific mission was created to go there, and basically a Pluto flash flyby, and that ended up being New Horizons, which did that in the summer of 2015. And, as much as the science team expected, a very heavily cratered, cold, icy, and dead world, what they found was something very, very different, a very much dynamic world where the heart feature you see on that image is actually an ancient impact basin. And there's enough heat left over from that impact that it actually mobilizes nitrogen and carbon monoxide and methane ices that flow as glaciers flow on Earth. And there's these unusual convective cells in this region where this material is mobilized by internal heat. Most of the crust is made up of water ice, which is as hard as rock is on Earth. But we see other exotic features. We've identified what appears to be cryovolcanoes on the surface. Cryovolcanoes means if you take water and add an antifreeze like ammonia or methane, it can rheologically behave the way silicate lavas do on Earth and actually build up, volcanic structures, volcanic mountains. And that's what you see in the middle bottom image there. And then, of course, the money shot, Pluto does have an atmosphere. It slowly freezes out as the planet moves away from it, probably sometime later this decade, and might disappear. But New Horizons flew by in time to see a very complex layered atmosphere. Solar wind, solar particles strike this material and produce unusual dark material called tholins, which accumulate on the surface. Studying the smoothest areas on the surface, we see very few impact craters. And of course, the amount of craters on a surface tells the surface's age. And when you find a surface that's lightly cratered, it's probably geologically young. And the area in that giant impact basin, Sputnik Planitia, is actually probably just 100 million years old. So Pluto is very, very far from a completely cold and dead world. It was one of the great surprises from the New Horizons mission. Class D in the Star Trek universe tend to be smaller, rocky worlds. They can be hot, they can be cold. The best analog to those would be something like the Earth's moon, which you see in the movie there from NASA's Lunar Reconnaissance Orbiter that arrived in 2009. It's still there, still collecting data, taking images. Professor Mark Robinson in my department at ASU is the PI of the camera system that allows us to get this wonderful color-coded digital terrain model of the surface, as well as images at relatively high resolution, as resolutions as high to visualize beach ball size objects on the surface. But of course, as we all know from the moon, you see it's very different. The near side with the giant impact basins filled with the ancient volcanic flows of the lunar maria, with a thinner crust, and then the farther side of the moon, which has a thicker anorthosite crust there and less of the lava being in place. It's been studied very heavily, not only by NASA, but by the European Space Agency, the Japanese Space Agency, the Indian Space Agency, and many others to investigate, and all sorts of interesting studies, including the identification of millions of metric tons of water ice preserved in permanently shadowed craters in the polar regions of this body. And that is a resource that could be utilized for a human settlement or base or outpost or something. So NASA is taking the next steps to do that. They're establishing the Lunar Gateway. You see that at upper left. It'll be a space station in cislunar space that will be NASA and international partners putting it together. And it will basically be a outpost that will enable sorties to the lunar surface. The commercial sector is developing instruments and spacecraft to study the surface. Other nations are moving forward. I just saw a report that the People's Republic of China is very intent and probably wants to have their own astronauts on the surface of the moon by the end of this decade. So there's a lot that's probably going to be going on here. Now, this chart here shows the current configuration of NASA's Planetary Fleet. I'll talk about more of the different things at the end of the talk. So focus instead on the block that says the moon, and you see the Lunar Reconnaissance Orbiter that is in there. LunaMap and Luna Trailblazer are CubeSats, basically shoebox-sized spacecraft that will be going up and launched on the first mission of the Space Launch System rocket. There's also various commercial payload services, landers being built, as well as a Viper, which is going to be a test of a small rover that can operate in the extreme cold and low light levels of the polar regions of the moon. So a lot is going to be happening there. Another example of a Class D object, a very small rocky body, would be things like dwarf planets. And in this case, I'm going to reference dwarf planet Ceres, the largest object located in the main asteroid belt between the orbits of Mars and Jupiter. It was the first object discovered at that location, which is what the number 1 means. On the right, you see the spinning globe that was obtained by the NASA Dawn spacecraft when it had got into orbit in March of 2015. I was a member of the Dawn science team and participated in the data analysis for Ceres. This world, also is not completely dead. We think the surface is the remnants of a relic ancient ocean that underwent hydrothermal alteration as it froze out and the heat dissipated. And when we look in some of the bright locations as it's going by, we see interesting features. We see what we think are cryovolcanic domes, where basically a salty and carbonate-rich fluid was able to erupt out of the interior and paint the surface in these volcanic-like domes and these bright materials, which you see down in the 2 photos there at lower left. So Ceres was so interesting from the Dawn mission that NASA asked us to do a study for what would be the next logical mission to go back to Ceres and try and answer the question of whether it is a relic ocean world. And so I was part of a science definition team that looked at a Ceres lander sample return concept. And the idea that was to get the most science for dollar spent would be something that would both land and grab samples and then return to Earth. And that's what this slide explains here. The idea of a spacecraft that's solar powered, the panels are deployed, and when it gets there, it retracts the panels, lowers, lands, redeploys them on the surface. It does the measurements and the sample collection of the surface. And then they're retracted again, it launches back into space, and then they deploy again and go back on the course to Earth where a sample return container would go. So this particular mission concept is being investigated for a possible future mission, along with many, many others, as we plan the priorities for the next decade of planetary exploration. Whether it actually happens, we'll see. But we did this study, and it's very, very promising of the kind of science that can be done. So let me move on to Class E in the Star Trek universe. They call them geoplastic. These are hot, molten surfaces, much like Io. There isn't really anything in our solar system quite like what they refer to in the Star Trek universe, but we have discovered some of these super Earth exoplanets that we think could be volcano worlds. And the idea behind these super Earth exoplanets is the densities suggest rocky compositions. They orbit relatively close to their parent stars. They probably have very high radiation environments, so life, at least life as we know it, would not be possible. They could have substantial atmospheres. More than likely, they have very large amounts of active volcanism. So another way to refer to this is lava planets. And we are using Io in our own solar system as a potential analog for studying planets like this. So moving on to Class F, this is geometallic. These would be worlds that would be, with molten cores, but have large concentrations of metals in their interiors and possibly on their surfaces. In the Star Trek universe, it was Janus 6, where they found the silicon-based life Florida. In our own solar system, probably the closest analog would be asteroid number 16, which is named Psyche. And that is the target of a mission that we are leading development on here at Arizona State University. The mission is called Psyche, named after its target. And you see a diagram of the spacecraft we've been building. We're in the final stages of assembly, testing, and launch operations, preparing for a launch about a year from now in August of 2022. The thing that makes asteroid 16 Psyche interesting is that it's an M-class asteroid. And in this case, M stands for metallic. We think it is the exposed core of an asteroid parent body that has been struck by multiple collisions that knocked off most of the crust and mantle, so that potentially a large fraction of the metallic core could be exposed on the surface. And the goal of our Psyche mission is to go into orbit at multiple orbits and analyze this object and try and determine if that is what it is. Is it a planetary core? Is it just a hunk of unmelted metal? Is it something that was metallic but reaccreted? All these questions will be answered, hopefully, by the instruments here. And if you're wondering the size of this, that's what the map of Arizona is. This particular asteroid is the size of the state of Massachusetts if you leave off Cape Cod, or the distance between Phoenix and Flagstaff. So it's a big asteroid. It's in a very stable orbit in the main belt, so there's no danger from it. Class G in the Star Trek universe here. These are carbon worlds there, where there's a major component of carbon dioxide in their atmospheres, but carbon could be crystallizing on its surface. Maybe it has life or not. In the real world there is a sort of a carbon world there called WASP 12b that was discovered in 2008 with extensive carbon, methane, and carbon monoxide in the atmosphere. And, you know, scientists who've studied it have likened that it may be a world made out of carbon. So maybe it's a world that is a giant diamond at its core. But it's one of a type of really exotic worlds that we're discovering using the various space telescopes and telescopes on Earth, for that matter, to explore exoplanets. So this is just one example of that. Class H would be desert type worlds. There's several of them that have been encountered in the Star Trek universe. They're rocky. They could have heavy atmospheres. They could have radiation or not. They could have life or not. An analog to an exoplanet that we have for something like this would be the super Earth that was discovered in the 40 Eridani system. And of course, that in the Star Trek universe is the planet Vulcan. This planet is 16 light years away. It's about 8 to 9 times the mass of the Earth. It orbits every 42, I think it says days there. I can't see because the zoom window is covering up my text. But it is just inside the habitable zone, so it's going to be very, very hot. But who knows whether a world like that could possibly have life on it. I'll turn off that. Yeah, hopefully you can still hear me. If not, maybe I'll turn the volume back on. Can you still hear me? Can you still hear me? Yep, okay, good. Yeah, that volume is in this wonderful movie that was made from the images from the NASA Juno mission. And Juno is a Jupiter polar orbiter, and it's got these great images of the atmosphere. It mostly studies the atmosphere and magnetosphere with other instruments. These and the Jupiter and the planet Saturn are analogs for the Class J, the gas giant planets. And of course, you know, there's lots of those out there as well. So, you know, we had great fortune of having missions to Jupiter between Galileo and Juno, and then the Cassini mission, which explored Saturn and its system of moons and rings, etc. And what we're planning on is a mission to go to the ice giants, which would be the planets Uranus and Neptune, which are different compositionally in the near future. So let's go on to Class K, adaptable, rocky, smaller rocky worlds, but with atmospheres, but they could have the resources that life could exist. You know, there's been several of those encountered in the Star Trek universe. What we see here on Earth would be the planet Mars. And you see a rotating globe of the planet Mars. You know, it has been the focus of NASA's robotic exploration since the mid-1990s. It's a world whose surface matches all of the continental area, surface area of the Earth. It's a world that has glaciers. It's a world that at one time had running water in lakes and streams, channels, and possibly even oceans. The image that's flickering at upper right over there are these unusual recurring slope linii, which they think could be locations where possibly very salt-rich waters could erupt out onto the surface and discolor it until the water boils away in the low pressure of the Martian atmosphere. Possibly these are just produced by granular materials, but you know, Mars is a world that, you know, canyons and active volcanoes, ice caps. Certainly it has a lot of resources, and it also has varying methane signatures, possibly indicative of a microbial biosphere underneath the surface. Many missions are going out there and have gone out there. This graphic that you see on the left shows the active flight missions that are still working at Mars. So Mars Odyssey is the oldest, that's 2001. The mission that I've worked on since 2004, Mars Express, Europe's first Mars orbiter, the Mars Reconnaissance Orbiter, the MAVEN, the European Trace, The ones in yellow are missions that are in development. The Japanese MMX, which will also study the moons Phobos and Deimos. The rovers on the surface, as I said, Curiosity and Perseverance are operating. The InSight geophysical lander is collecting data on Mars interior and earthquakes. Well, Mars quakes is the better term. The European Rosalind Franklin is going to probably launch within another year or so. And then the NASA ESA joint sample return mission will be developed during the next decade. So the Perseverance rovers, the first step, it's collecting drill cores, putting them in titanium containers to preserve them. The next step would be to send a lander with a sample retrieval rover, which will pick up all these samples in their containers, put them onto the spacecraft. The spacecraft will launch an ascent vehicle from the surface of Mars to Mars orbit, and then a third vehicle will collect those samples and return them to Earth. And that's all going to happen in the latter part of this decade. So Class M in the Star Trek universe, from the Vulcan Minshara class, as we learned in Star Trek Enterprise, are Earth-type planets, planets that have hydrospheres and atmospheres and biospheres where people like us live. There's been a whole host of worlds that are Earth-sized that have been discovered by the NASA Kepler mission for exoplanets. The first one you can see over there. See if I move that. July 2015, first near Earth-sized planet orbiting a sun-like star. There have been many of these. 60% larger than Earth, so it's a super Earth, orbits a G-type star in 385 days, so it's very close to our year. Likely a rocky planet, 1,400 light years away, star 6 billion years old. So you got the potential there. It's got all the ingredients for something like that. Let's see here. Class N, reducing atmospheres. These are ones with thick carbon dioxide atmospheres with sulfides or sulfur dioxides in it. The closest analog to something like that would be the planet Venus. And, Venus, our sister world in terms of size and mass and density, but that's where the similarities end. When you go down to the surface, it's a volcanic and structural geology disrupted world. Got a couple of big continents color coded in there, but it's got that very thick atmosphere, 90 bars pressure, 900 degrees Fahrenheit at the surface, sulfuric acid clouds just eat spacecraft when they get down there. We mapped it well with the Magellan mission. I was part of that in grad school, the surface using radar to penetrate the opaque atmosphere, but it hasn't been studied that intensely since then. But there's intriguing information that's come from all of the missions, and the idea that at one point Venus may have been Earth-like. Maybe it had an Earth-like ocean. That ocean disappeared for some reason. Why? These are important questions. And NASA has selected as the next two Discovery class missions this year. They announced it in June this past summer, of two missions that are going to go there. Da Vinci Plus, you see, has an atmospheric probe on a parachute. It's going to stay up above the nasty sulfur dioxide clouds toward the bottom of the atmosphere and analyze the composition of the atmosphere at a higher level, which might be conducive to some form of microbial life. Veritas, you see, has got a high resolution radar mapper. It's going to make maps of the surface with radar that is much higher than what Magellan was able to do back in the 1990s. So both of these missions are going to be functioning. They were just approved, so it's going to take 5 years or so to build them before they launch. The European Space Agency also approved a Venus mission. So the long neglected planet Venus is finally going to get its due with modern instruments. So a class O world in the Star Trek universe is a pelagic planet. In other words, it's an ocean world where a liquid water ocean exists on the surface. Now, we haven't really, there's obviously nothing quite like that on our own solar system, and it's unclear whether that's been detected by exoplanets. The closest equivalent would be the first gaseous exoplanet with water vapor in its atmosphere was discovered in September and announced in 2014. So Hubble and Spitzer Space Telescopes reveal H2O and H2 gas. This is 26 Earth masses, 4 Earth radii, so a very, very large world. Temperature is about very hot, 1,100 degrees Fahrenheit, 120 light years away. So if it is an ocean world, it's a very, very hot ocean world. So I don't think anybody would be swimming in that ocean. Class P in the Star Trek universe is Glaciated World. So these are ones that have ice covering the surface. And we find that there's a lot of worlds in our solar system that probably have liquid water oceans in the interiors and are covered by ice. The one that you see displayed here would be Jupiter's moon Europa. It's the second moon out from Jupiter past Io. It's affected by tidal heating, but because it's an icy body, the tidal heating and flexing melt the ice to form a salty liquid water ocean that exists maybe somewhere between 1 to 10 to 25 kilometers underneath the ice. And these are images from the Galileo mission, which confirmed the existence of that ocean. We are building a spacecraft called Europa Clipper, which is scheduled to launch in, I think, a year or two. And it is going to head out there. It's going to be a Jupiter orbiter, but the mission is constructed, so it's going to get global coverage of Europa through many, many flybys out there. And we'll be able to determine, was there any nature of habitability on Europa? Another mission, and here you see details on Europa Clipper on the left. Another mission by our European colleagues, their first large planetary mission or L-class mission is called the Jupiter Icy Moons Explorer, or JUICE. And it is going to be an orbiter of Jupiter's moon Ganymede. Ganymede is the third Galilean satellite moon out from Jupiter. It's larger than the planet Mercury. It's also the only moon which has its own self-generated magnetic field. So, you know, its surface has been modified by tidal heating, although not as extensively as Europa and Io. So this mission is going to go into orbit, first of Jupiter and then of Ganymede, map the surface and study it with a variety of instruments to understand if this could have once been a habitable world at some point. And Professor Jim Bell and I are co-eyes on the camera, the Italian camera on this mission. Hopefully NASA will give us some money when it gets there to actually be able to participate in the exploration of this world. So to conclude, I bring you back here. So white on this chart are missions from the past. Green are missions that are either approved or in flight or operating. And things that are yellow, things that are orange, like MSR, Mars Sample Return, that is in development. Not all parts of it have been funded or approved yet. Missions that are in yellow have been proposed, but are not currently funded. So you see, we want to go back to Io. We want to send an orbiter out to either Uranus or Neptune, ideally both, but that's a really expensive proposition. So there's still a lot of room and a lot of great exploration, but a lot is happening now and will be happening through this decade. And so here is the Planetary Fleet chart. We've talked about Moon and Mars. You see New Horizons is exploring the Kuiper Belt. These missions that are in orange text there are in development now. I've already mentioned Clipper, I've mentioned JUICE, I've mentioned Psyche. DART is a double asteroid redirect mission. It's going to be a planetary defense mission to see, is it possible to change the orbit of a small satellite asteroid around a larger asteroid? Excuse me. OSIRIS-REx is returning its samples from asteroid Bennu. Bepi Colombo is on its way to Mercury. I mentioned Veritas and Da Vinci, and Vision is Venus's mission. Lucy, that is a mission that's going to visit the Trojan asteroids of the planet Jupiter. And that mission is actually scheduled to launch later this year. And I mentioned Juno and Dragonfly. Janus, I think, is a pair of CubeSats, the missions that are going on. So lots and lots is going to be going on, and there'll be plenty to talk about in future years. So just in conclusion, NASA's Planetary Exploration program is very vibrant, with spacecraft visiting many different types of worlds in our solar system. Likewise, the exoplanet missions are continuing to discover new planets around other stars in our galaxy that are very different from some of the worlds we have in our own solar system. So rocky terrestrial planets, gas giants, ocean worlds, small bodies have all been visited or will be visited in our own solar system. What's missing? Well, missions to ice giants. Those are Uranus and Neptune type gas giant worlds. Io, a volcanic tidally heated world. Triton, also probably a lot like Pluto, perhaps a captured Kuiper Belt object. And some of the more water-rich asteroids and comets have not been visited yet. You can't do everything at the same time. So hopefully that is going to occur in the coming years. So with that, I will stop sharing and we return here, and I will take questions from the audience. So you can type it into the chat window, or maybe Randall, if he's here, can unmute folks, and then we can ask your questions yourself. So thank you.
Okay. I don't believe you actually need me to unmute you. I think you can do it from your own board. And since we're a relatively strong
Everybody
group,
there?
yeah, I probably won't need to.
I see one question in the chat window. It says, where will the recording of this be available? So Randall, you'll have to answer that question.
Okay, when after the convention, I will Dropbox the recording over to.
And I can't hear, so.
Sorry.
There we go.
Yeah, after the convention, I'll Dropbox my recording over to D on the convention committee, and hopefully it'll turn up on the CoKoCon website at some point.
Okay. Can any in the audience there on Zoom, can they unmute and ask questions?
I believe so. I think you've got your own control. If not, put something in the text, and I'll see if I can fix it for you.
Yeah, I can now see the chat window. So does anybody have any questions? I know I went through an awful lot, the whole solar system and a few exoplanets in a very small period of time, but happy to answer any questions anybody might have.
Okay.
I'm disappointed to see that there are no crewed missions on the horizon yet.
There are not any crewed missions on the horizon. Is that what you're asking? Yeah.
Just commenting that that's disappointing.
Yeah, no, I agree. We had so much during the shuttle era to low Earth orbit, and everything is so far is focused on the International Space Station, but NASA is training astronauts for going back to the moon as part of the Artemis program. And the original plan in the prior administration was that we would send US astronauts down to the surface of the moon by 2024. I think that's a bit ambitious because, when you get to that level, again, it's more expensive. And, when you have governments that don't like to spend money on big projects, that's seldom likely to happen. But I think it will happen. I think we will have US astronauts have boots on the surface of the moon, maybe by mid-decade, maybe by 2026. I think a lot of people think that if the Chinese are going to go there, that we need to go there too, for a variety of reasons. I think there's a great desire to set up some sort of a permanently staffed outpost, much like McMurdo Station in Antarctica. So yeah, for those of us in the sci-fi community have dreamed since the 1980s that, we went to the moon, we should be on Mars, we should be doing more things with human space flight. And, but it's expensive, and it's hard to convince politicians to do that. They have other priorities. So, but I think we're at the point now where the commercial sector is helping and developing things that we're going to be able to get out there.
I was just going to pivot and ask about that. One of the things that's encouraging is that so many other nations are getting into space, and it looks like they're sending out probes, and we're going to get a lot of great data from that. Mm-hmm. Is that proliferation going to continue, and diversifying the fleet, so to speak, sounds like a really good idea to me. And just wondering how private enterprise is going to get into the scientific exploration and data collection aspect of this.
Yeah, I can answer that. The answer is yes, there are more nations doing planetary exploration now than any time in the past. Matter of fact, the United Arab Emirates sent their first Mars orbiter mission there. We built a thermal camera at Arizona State University that's on that mission. South Korea is building a lunar orbiter with a special camera that can see in very, very low light levels, such as the permanently shadowed regions of lunar craters. Professor Mark Robinson is the PI on that mission. So yeah, a lot of nations that hadn't been doing planetary exploration before are now getting into that, and I expect that to expand. Now, the commercial sector, I think, is more focused on enabling things in low Earth orbit, or as contractors building instruments or components for other things rather than leading planetary missions right now. But their role is also increasing, as I understand it. So I think it's entirely likely that, they will have an increasing role in solar system exploration as the years go by.
Well, does private enterprise have a role in scientific exploration, or are they going to keep their findings to themselves for their own purposes?
That's a good question. I'm not aware of private enterprise doing a lot of just pure scientific exploration. I see them more as focused on techniques and development of things more related to what NASA needs. I mean, just look at the various corporations that are building spacecraft to take humans and cargo to low Earth orbit to supply the International Space Station or to do space tourism. That's where I see a lot of things right now. Now, there has been talk about private companies building, satellites to search for resources on near Earth asteroids or help, gather them on the moon. So I suspect that would probably be the area where they would contribute in the near term. There's another question in the chat. It says, are there any further New Horizons encounters planned? The New Horizons spacecraft is continuing to function as it moves deeper into the Kuiper Belt, and they've been doing distant observations of Kuiper Belt objects. They are trying to do a campaign to identify any Kuiper Belt object that might be close to its flight path that they might be able to do and get more information on any Kuiper Belt objects. So I think they are proposing to NASA for an additional extended mission to do that. And if that is approved, then they will continue. But as of right now, yes, the New Horizons spacecraft is continuing to gather data as it moves deeper in the Kuiper Belt, but from much more distant objects. Other questions?
Yeah. When an object does not have an atmosphere, I'll share my video. When an object does not have an atmosphere, the solar wind can erode the material off of that object and collect it into the magnetotail. Are there experiments to look for the materials eroded off and ionized within the magnetotail? This would give bulk compositions of the object.
Yeah, Mike, I think so. Of course, this is out of my area of specialty, so I can only say a broad overview of it. But I think the NASA missions that have components, I think Cassini tried to do a little bit of that, and I think Juno tries to do a little bit of that type of stuff. I don't know that any mission has been dedicated to looking at that particular detail. I also think New Horizons, tried to do some of that around Pluto, but I just don't, have that kind of detail on that to expand further.
It seems easier than a landing mission to examine material that is eroded off.
Yeah, for example, there's proposals for a mission to Enceladus, one of the moons of Saturn, that has the plumes at the South Pole and is ejecting material from its internal ocean. And Cassini wasn't well designed for that, but the new mission, if it was to be approved and funded, would have exactly those kind of instruments that you fly through the plume and you would be able to do a rigorous examination of that. So, it's just another step, to have something that can fly through magnetospheres and do that. It's just the budget is so limited, you can only do a certain number of missions at any one time. And, these all go through community review and peer review, and the ones that are the most cost effective and least risky tend to be the ones that go first until technology development can come and make others less risky. But, this is an ever changing and ever growing situation.
Okay, thank you.
You're welcome. Other questions, either in the chat or here online?
Okay, kind of a physics thing that's been running through my mind for many years. I've often heard the explanation for Io's volcanoes that the crust is undergoing flexural or tidal heating. Ultimately, where is that energy coming from? Is it coming from the spin of the moon or from its orbital velocity or what?
It's a combination. It's a force eccentricity due to a gravitational tug of war between the planet Jupiter on one side and the Mercury-sized moon Ganymede on the other. The Io, Europa, and Ganymede orbit in what is called a Laplace resonance. And so what that means is in the time it takes Ganymede to go around Jupiter once, Europa goes around twice, and Io goes around 4 times. And so what that does is it causes the crust of Io to flex up and down 100 meters every, it's about 48 hours is usually what I tell people. I think it's 1.7 days is the exact number. But yeah, that gravitational pull of it and causing this force eccentricity in the orbit, that's what causes this heat generation, and it's enough to melt the deeper layers to produce an asthenosphere that could be a magma ocean. It may not be fully, it may be up to like 25% molten. It may not be completely molten, but there's a lot of hot stuff down there. And one of the big questions is the material erupting out at its hottest, is it basaltic like in Hawaii, which would have an eruption temperature around maxing out at around 1200 degrees? Or as some instruments have suggested, could it have something more like a komatiite, which is an ultramafic, high magnesia, low viscosity lava that erupted on Earth 2 to 3 billion years ago, which I studied for my doctoral dissertation. Randall will recognize the term, but for the rest of you, this type of lava is very, very fluid. If you think about the lavas in Hawaii, they have a viscosity somewhere between mayonnaise and creamy peanut butter. A komatiite lava would have a viscosity more like olive oil. So imagine the Mississippi River filled with olive oil at 3000 degrees Fahrenheit. That is a very, very hot, very, very fluid lava. And those things erupted on Earth, back in the Archean and the Proterozoic for you geologists out there. But there's some evidence that those may erupt occasionally on Io. And one of the goals of the IVO, the Io Volcano Observer, will have advanced imaging type of instruments to actually be able to measure the hottest material as it erupts on the surface in flows to determine, is it actually ultramafic or is it more basaltic, more like Hawaii? And that will place constraints on the internal heat.
Okay, ultimately, like I say, you've drawn energy out of the system and turned it into heat. So in the very, very long scale of things, does that mean the orbits of Io and Ganymede are being drawn closer together?
I don't know whether they're closer, but you do touch, what you're saying is sort of a conundrum, because if the level of geologic activity in Io had been going on since the beginning of the solar system 4.5 billion years ago, Io should be completely reprocessed, and it should not have the more primitive basaltic and komatiitic materials on the surface. It should be all processed to something much more advanced, yet it doesn't. And so that leads to the conclusion that the Laplace resonance that we see that Io and Europa and Ganymede are in now may not have existed throughout the entire history of the solar system. It could be something that is relatively recent. Now, what does relatively recent mean? Well, in geological terms, we're talking about something hundreds of millions of years to 1 billion years, but certainly not something as long as 4 billion years. So this is one of the things that fascinates me, and one of the great discoveries since the 1990s is that the way the solar system is set up now in its current configuration is not the way it's always been. The giant planets have migrated from their original positions into their current positions. And when you move those gas giant planets around, they disrupt everything. They disrupted the main asteroid belt. They disrupted the Kuiper belt. Some say that could be why we see evidence of a late heavy bombardment on the rocky inner planets. It's a very subject that there's a lot of research and a lot of investigations going on about that. Okay, there's another question down here. Would the Ceres sample return mission just sample one spot, or would it visit several sites? That's an excellent question. When we were developing it, we were hoping it could do, in your pipe dream, you'd like to go to like maybe 3 locations, but you sort of settle for 2. In the end, the current study, it would just land at 1 location. And the reason why is it costs mass, which increased the cost of the mission to put on the additional fuel to travel, to land, and to take off, and then go and land and take off again. So the more times you try and do that on an airless body, land and take off and land and take off and land and take off, that increases the amount of fuel that you need, which increases the mass of the spacecraft, which increases the cost of the mission. So if you can figure out the one sweet spot where you have multiple materials in close geologic contact, where you have the bright stuff with all the salts and carbonates, as well as some of the darker material that could be remnants of an ancient ocean, you want to grab both at the same time, and then you only need to land in one spot. And that's sort of the conclusion that we came from in that particular study. Are there other questions, either in the chat or here online? I would remind folks that I'm doing another space science talk on Monday on the Saturn's moon Titan, what we learned about it through the Cassini mission, and then look ahead to Dragonfly. Dragonfly is going to be a medium-sized New Frontiers class mission. It's going to launch in 2027, get there in 2034. And it's basically an aerial drone with 8 sets of helicopter blades that's actually going to be able to land on the surface in multiple locations and retake off. It's got sample devices on it. It's going to be very, very interesting. So if you're free on Labor Day and here at the con, you can come and hear me talk about that. Other questions now? Everybody's satiated with solar system science.
I'll be the first to thank you for another excellent talk.
Thanks, Mike.
Come see our club in a couple of months.
Yes, I am going to be there with you guys there before the end of the year. Thanks, my brain is full. Okay. Yeah, I'm glad that they decided to do this, to set this up through Zoom. You know, I know we'd all like to be together in person during the pandemic, and if it weren't for the pandemic, and you know, I'd have my new planetary posters to give away there, but they'll still be there when hopefully we can come back together a year from now in person, and then there'll be even more things to talk about.
All right, that sounds like a good breaking point then. I'll hit the stop recording button momentarily
Alrighty.
and then work out how to get that back to the CoKoCon so that you can come back and see it another time.
Yep. Thank you, everybody, for attending. I appreciate it.